Imagine investing hundreds of millions in cutting-edge air defense only to face unexpected challenges in the desert. Today, we analyze Saudi Arabia's Chinese-made air defense systems, their performance issues, and what these technical challenges reveal about modern military technology. Hello everyone, welcome back to the channel. Today, we're examining a critical topic in military technology, Saudi Arabia's Chinese air defense systems and the operational challenges they have faced. The Kingdom of Saudi Arabia has one of the most advanced defense setups in the Middle East, designed to protect critical infrastructure, including oil facilities and key urban centers. In recent years, Saudi Arabia invested in advanced air defense technology from China, particularly the Silent Hunter laser system, which is designed to neutralize drones and low-altitude threats. These systems promise rapid targeting and cost-effective defense compared to traditional missile systems. However, when deployed in the harsh desert environment of Saudi Arabia, reports indicate that the systems faced several performance challenges, including difficulties with precision, cooling mechanisms, and operational reliability. Today's video will explore these challenges in detail, examine the technical factors behind them, and highlight the adaptations made by Saudi Defense Forces to maximize effectiveness. We'll also analyze what this situation reveals about the broader adoption of cutting-edge military technology in extreme environments, and why understanding these limitations is crucial for defense planning. By the end, you'll have a comprehensive view of the real-world performance of Saudi Arabia's Chinese air defense systems without any exaggeration or speculation. Saudi Arabia occupies a strategic position in the Middle East, with vast reserves of oil and critical infrastructure that are vital to both national and global energy security. Protecting these assets is a top priority, particularly against emerging threats like unmanned aerial vehicles, drones, and low-flying aircraft. The attacks on Saudi oil facilities in 2019 highlighted vulnerabilities in traditional air defense setups, emphasizing the need for faster and more precise systems. In response, Saudi Arabia explored modern alternatives, including laser-based air defense technology. The Silent Hunter system, acquired from China, was designed to complement existing missile-based systems, offering rapid engagement of multiple low-altitude threats. The adoption of such advanced technology demonstrates Saudi Arabia's willingness to integrate diverse solutions from international suppliers. While the technology shows promise, real-world deployment revealed significant operational challenges due to extreme environmental conditions, including desert heat, dust, and sand. These factors affected system performance, revealing a gap between laboratory capabilities and field effectiveness. Understanding Saudi Arabia's defense needs is critical to comprehending why these systems were acquired, how they fit into the broader strategy, and why performance optimization in harsh environments is a major factor in evaluating the success of advanced military equipment. China's Silent Hunter laser system represents a major step forward in directed energy air defense technology. Developed by the China Electronics Technology Group Corporation, the system is designed to intercept drones, small aircraft, and other low-altitude threats using high-energy laser beams. Its advantages include rapid targeting, precision engagement, and reduced cost per intercept compared to conventional missile systems. The system is also compact and modular, making it suitable for deployment alongside traditional air defense arrays. Saudi Arabia's interest in the system stemmed from these technological capabilities, combined with the desire to diversify its defense suppliers beyond Western countries. However, while the system performs well in controlled environments, field deployment has highlighted the importance of environmental adaptation. Reports from Saudi Arabia indicate that extreme temperatures, dust, and sandstorms impacted the system's cooling and targeting mechanisms, occasionally reducing its effectiveness against small drones. Despite these challenges, the Silent Hunter remains operational, and the Saudi military continues to implement modifications and operational protocols to optimize performance. This case underscores the complexities of integrating cutting-edge technology into real-world conditions, emphasizing that even highly advanced systems require careful adaptation and continuous monitoring to perform as intended. Deploying advanced laser air defense systems in the desert environment of Saudi Arabia presents unique operational challenges. The country experiences extreme daytime temperatures, often exceeding 50 Celsius, along with frequent sandstorms and high levels of dust in the air. These conditions create multiple technical difficulties for high-energy laser systems like the Silent Hunter. Excessive heat can impact cooling mechanisms, potentially causing temporary shutdowns or reduced beam power. Dust and sand particles interfere with the laser path, affecting targeting precision and reducing the system's ability to neutralize small or fast-moving aerial threats. Furthermore, the desert's reflective surfaces, including sand dunes, can cause beam scattering, which requires calibration adjustments. Saudi military personnel have implemented operational measures to mitigate these effects, including scheduling maintenance cycles, shielding sensitive equipment, and optimizing software for desert conditions. The environmental impact demonstrates that while advanced military technology offers significant advantages on paper, real-world deployment requires extensive adaptation. By understanding and addressing these challenges, Saudi Arabia continues to enhance the reliability and effectiveness of its air defense capabilities, showing that environmental factors are as critical as technical specifications in determining operational success. Operational data from Saudi deployments of the Silent Hunter system indicate that the system can successfully intercept multiple drones under optimal conditions. However, performance metrics in the field show variability due to environmental and operational factors. During sandstorms or extreme heat, the system's response time may increase and beam accuracy can decrease, affecting engagement effectiveness. Reports suggest that maintenance and calibration are crucial for maintaining operational readiness, requiring trained personnel to regularly monitor and adjust system parameters. Despite these challenges, the system has contributed to Saudi Arabia's layered defense strategy, complementing traditional missile systems and enhancing protection against low-altitude threats. Analysts note that these operational insights are not unique to Saudi Arabia. Many advanced military technologies face similar challenges when deployed in harsh environments. The lessons learned highlight the importance of field testing, continuous adaptation, and personnel training, demonstrating that performance metrics must account for real-world conditions rather than relying solely on laboratory specifications. To address operational challenges, Saudi defense forces have implemented multiple adaptations for the Silent Hunter system. Protective enclosures reduce exposure to dust and sand, while advanced cooling protocols mitigate the effects of extreme heat. Software updates have improved targeting accuracy under variable environmental conditions, and maintenance schedules have been intensified to ensure consistent performance. Personnel training programs now emphasize rapid response procedures and system calibration, ensuring that operators can maximize effectiveness even during adverse conditions. Additionally, the system is integrated with existing missile defense infrastructure, creating a layered defense approach that compensates for any temporary performance reductions. These solutions demonstrate that challenges in military technology are often addressed through a combination of hardware adjustments, software optimization, and operator expertise, rather than abandoning or replacing systems outright. The Saudi example underscores the practical realities of modern air defense, where environmental adaptation and procedural discipline are as crucial as the underlying technology itself. The Saudi deployment of the Silent Hunter system offers several technical lessons for military planners worldwide. First, high-tech systems must be tested in environments that closely resemble actual operational conditions. Laboratory performance alone is insufficient for predicting real-world effectiveness. Second, environmental factors such as temperature, dust, and terrain can dramatically influence system reliability, requiring both design adaptations and operational protocols. Third, personnel training and maintenance routines are critical to ensuring that advanced technology performs as intended. Finally, integration with existing defense infrastructure is essential for maximizing protection and creating redundancy. These lessons extend beyond Saudi Arabia. Serving as a guide for countries is adopting cutting-edge military technology. Understanding these factors ensures that investments in advanced defense systems deliver tangible operational benefits and do not encounter avoidable performance limitations in the field. Saudi Arabia's experience with Chinese air defense systems also carries broader strategic implications. The adoption of non-Western military technology signals a willingness to diversify suppliers and reduce dependence on a single source for critical defense needs. At the same time, it emphasizes the importance of realistic assessments of technology capabilities and environmental suitability. Countries investing in advanced defense systems must balance cost, performance, and operational adaptability. The Saudi case demonstrates that even highly advanced systems require continuous monitoring, adaptation, and technical support to achieve strategic objectives. For global defense analysts, this scenario provides a concrete example of the intersection between technology, environment, and military strategy, highlighting the need for comprehensive evaluation before committing significant resources to new defense systems. Media coverage of the Silent Hunter system often focused on operational challenges, sometimes using sensational language to describe the performance issues. Headlines referring to failures or scams can create misconceptions about the system's effectiveness. In reality, these challenges reflect the complexities of deploying advanced technology in extreme environments rather than deliberate design flaws or misrepresentation. Accurate reporting and analysis are essential for understanding the technical realities and preventing the spread of misleading narratives. Saudi Arabia continues to operate the system effectively within its broader air defense strategy, and public perception should reflect the practical challenges of field deployment rather than sensationalized claims. The case demonstrates the importance of separating technical realities from exaggerated narratives in media coverage of military technology. Looking ahead, Saudi Arabia is likely to continue refining the deployment of its Chinese air defense systems, incorporating lessons learned from environmental and operational challenges. Continued software updates, hardware modifications, and operator training will enhance performance and reliability. The experience underscores the importance of adaptation and continuous improvement in modern military operations. While the system faced challenges, it remains a valuable component of Saudi Arabia's layered defense strategy. This case also highlights the broader implications for military technology adoption globally, demonstrating that advanced systems must be matched to environmental and operational conditions to achieve their intended benefits. By learning from this experience, Saudi Arabia and other countries can optimize future defense acquisitions, ensuring that investments in technology deliver real-world protection and operational effectiveness. If you found this analysis insightful, don't forget to subscribe, and hit the bell icon for more detailed military technology insights. Share your thoughts in the comments on how advanced defense systems adapt to real-world conditions, and stay tuned for our next in-depth analysis.